Hello, welcome back to algebra class. Today we're going to be talking about solving systems of equations by graphing. So to be able to solve a system of equations by graphing and determining how many solutions there are. First up, we know we have a system of equations if we have two or more linear equations using the same variables. The solution to finding a system of equations is an xy ordered pair that makes both the equations true at the same time. On a graph, it would be where the two lines intersect or cross. So today we're going to be talking about graphing systems of equations. So we have a couple different examples here. Here's our first example. And if you notice, the two lines cross at that point right there. And you'll also notice that they cross one time, so we would say we have one solution. Our next example looks like it's one line, but actually what we have is two lines right on top of each other. So basically we have a line going like this, and we have another line right on top of it going like this. So what's happening is those two lines are actually always crossing, so we would say that we have infinitely many solutions. Our last example is two lines that, as you can see, never cross. So we would say that they have no solutions or zero solutions. Let's look at our examples here. It says to determine how many solutions each system has. So for our first example, I'm going to go ahead and I have y equals negative x plus 5. So that equation is right there. Next up, I have y equals negative x minus 4, which is this line right here. And it's pretty obvious to see that they have no solutions, so we write no solutions because they never cross. Go ahead and erase that for our next example here. So next up we have the equation y equals 2x plus 14, which that line is right there. We have 2x plus 2y equals negative 8, which is this line right here. And we can see that they cross right at that point right there. So we would say that we have one solution. And we'll go ahead and erase that. Our next example is 2x plus 2y equals negative 8. So we get this line right here. And we also have y equals negative x minus 4, which is also that line right there. So that is actually the same line. It's right on top of each other. So we would say infinitely many solutions. And we are good to go on this example. So when do we want to solve a system of equations by graphing? Because we can solve a system of equations in many different ways that we'll be talking about throughout this unit. And in this case, we want to solve a system of equations by graphing when both equations are in slope-intercept form. That means both are in y equals mx plus b. Now, you can still solve an equation by graphing if they are not in slope-intercept form, but it's not going to be the fastest and most efficient way. So let's go ahead and look at a couple examples on how to solve this here. So it says find the solution to the system of equations by graphing. So the first thing I like to do is draw a line right below my two equations. I have my red equation right here. So I'm going to rewrite that red equation as y equals 0 x's, because I have 0 x's, plus 3. Now, my y-intercept on this equation, it is always going to be whatever that plus or minus number is on the end of the equation. So it's 0, 3 in this case. And my slope is always written as a fraction, so it is 0, so it's just going to be 0 over 1. Anytime it's not a fraction, we just put it over 1. Now I can actually graph that pretty easily. So my y-intercept was 3, so I start right at 3. And then I rise 0 and I run 1. So I rise 0, run 1. 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 You get the picture, so it's just going to keep going that way. If I want to go backwards, I can do the same thing. You just have to maintain the same pattern backwards. I like to put as many dots as I can because it makes my line easier to make straighter. And I go ahead and just make a nice straight line that goes through all those points. Let's go ahead and take care of our green equation here. So on that one, it is already in slope-intercept form, so I don't have to rewrite it in any special way. My y-intercept on this one is going to be that -3, so it's going to be 0, -3. And then my slope on this problem is actually in a fraction. That's my rise over my run, so it's going to be 3 over 4. So I start on this one at -3, and it tells me, my slope tells me to rise 3 and then run 4. So I'm going to rise 3, run 4, and then put a dot right there. I rise up 3 squares, I run over 4 squares. I rise 3 squares, run 4, and I'm actually off my graph. I can actually maintain the pattern backwards though, so I would have to go backwards 4 and down 3 to do that. Backwards 4 and down 3. Then I'm going to go ahead and connect them in a nice straight line. And if you look, these 2 points actually intersect right there. So we need to actually name that point in order to have our final answer, which that point is 8, 3. So it's going to be 8, 3 is our solution area on that problem. Let's go ahead and look at our next example here. So I'm going to draw a line. My first equation, we'll make that one purple this time. So on this one, my y-intercept is going to be 0, 3. My slope is actually -1, so you can write that as -1, but it's not a fraction, so we're going to make it a fraction. So it's going to be -1 over 1. So I start at 3, and the -1 tells me to go down 1 over 1. So I'm going to go down 1 over 1. Down 1 over 1. Down 1 over 1. And I'm just going to continue that pattern all the way till I run out of space. Do the same thing backwards. Make a nice straight line. Okay. Now I'm going to go ahead and we'll use blue for this one. So on this one, I really have a plus 0 on the end there. So my y-intercept is going to be 0, comma 0, and my slope is going to be 1 over 2. So I start at 0 here, and I rise 1 and run 2. Do the same thing backwards, making a straight line. And once again, my graph actually crosses right there, which what is that coordinate? That coordinate is 2, comma 1. Move on to our next problem. So I'm going to go ahead, draw my line. We'll go red for my first equation. So my slope, my y-intercept is going to be 0, comma 5. And my slope on this one is that negative 1 again. So I'm going to write that as negative 1, but it's not a fraction, so I make it 1 by just putting it over 1. So I'm going to go ahead, put a dot at 5 on the y-axis, and I go down 1 over 1. So down 1 over 1, maintain that pattern. I can go backwards as well. Draw a nice straight line. We'll go purple on the next one for fun. So my y-intercept is 0, comma 2. My slope is, once again, negative 1 over 1. So I'm going down 1 over 1. And some of you might be seeing what is about to happen here. And what we have is two lines that have the same slope, so that means they never cross, so we would say that there are no solutions. Another way to write no solutions is called the null set. You can just make a 0 with a slash through it. If you want to know how I just said that, it's null, N-U-L-L. So no solutions for that. Okay, let's look at our last example here. So we have a line. Let's go green for our first one. So we have our y-intercept is going to be 0, comma negative 3. Our slope is negative 2 over 1. So I start at negative 3, I go down 2 over 1, down 2 over 1, down 2 over 1. Maintain the pattern going backwards as well. Draw a nice straight line. Next up, I have my next equation. However, we'll call this our blue equation. This is not in slope-intercept form, so I need to get y by itself. So my first step to do that would be to subtract 4x on both sides. So I would get 2y equals negative 4x minus 6. Next, I can actually divide everything by 2. So I get y equals negative 2x minus 3. And now I do have my y by itself, so I can figure out my y-intercept is going to be 0, comma negative 3, and my slope is going to be negative 2 over 1. You'll probably notice that that is actually going to be the same exact line as our original green equation. So we can actually say that has infinite solutions. Another way to write that would be like this. It's a R with another line down it. You can either say infinite solutions or you can write that R for all real numbers. That brings us to an end for today's lesson. Have a great day.